We can create parametric component families to allow us to change their key properties, their dimensions and materials, by adjusting parameters. Parametric families are very useful and easy to work with because they can easily be adapted as needed to meet our modeling needs. Let's start by creating a new Revit family, and we'll add parameters to this family definition that let us dynamically change it. Open the Revit menu and choose New, then Revit Family. We'll start by choosing a template for this new family from the Templates section of the library. Every Revit family is based on a template that specifies the category for this family and any special hosting requirements. Most families can be placed anywhere in a project model, but some families are defined as being wall-hosted or ceiling-hosted. Components from these families can only be placed on the appropriate hosting element. Let's choose the Furniture template to create a new console table with no special hosting requirements. Users of this component will be able to place it anywhere in a project. Before we get started modeling, let's save this new family to the library and name it Console Table. Open the plan view for the reference level. You'll see that there are two reference planes that have already been defined as part of the template. These are center front back and center left right. The intersection of these two planes is the placement point, the reference point on the component that will be placed at the point where you click the mouse as you're placing the object in your model. We'll add new reference planes to define the boundaries of our new console table. First, place reference planes running left to right on both sides of the center front back plane. These will be used to define the front and back sides of our table. Then, place reference planes running from top to bottom on both sides of the center left right plane. These will be used to define the left and right sides of our table. Now, let's switch to an elevation view. We'll also add a reference plane to define the top of our table. We'll give this one a name, so it will be easy to identify later when we are setting the work plane. Place it and let's name it Tabletop. Let's add some dimensions that will give us the ability to dynamically reposition these reference planes. First, let's create a dimension between the left, center, and right reference planes. We'll set the equal constraint to make sure that the left and right sides are always positioned equally around the center line. Now, we'll add an overall dimension between the left and right sides. We'll use this dimension to control the length of our table. Rather than giving this a fixed dimension, let's add a parameter to this definition line that will let us dynamically change it as a property of the table. Select the dimension, then open the label pull-down in the options bar and choose Add Parameter. We'll leave this set to a family parameter. Give it a name. Let's call it Table Length. Now set this as a type parameter. That means that this dimension will be the same for all components of the same type. To change this dimension, the user would define a new type and set the desired size as a type property. This will be a parameter of type length, and we'll leave it grouped in the dimension section of the properties dialog. Next, we'll add similar dimensions between the front and back reference planes. First, add dimensions that will set to equal to make sure the front and back reference planes are always equally spaced about the center. Then, we'll add a dimension that we'll use to set the width of the console table. Select this dimension and add a parameter to it. We'll call this one Table Width. It will also be a type parameter. It will have the type Length, and we'll also leave it grouped in the Dimensions section of the Properties dialog. We can switch to the Elevation view and add a similar dimension to set the height of the console table. This one won't need the equality constraint since we want the table to be placed above the reference level. Add a dimension between the reference level and the top reference plane, then add a parameter to this dimension. We'll call this one Table Height, and it will be a type parameter of type length in the dimension section of the properties. Now that we've created parameters to move the reference planes, let's test them to make sure they have the desired effect. Open the Family Types tool. The parameters that we've added in the last step appear in the dimension sections of the dialog with values measured from the current model. Enter a new value for the table width, then click the Apply button to verify whether the reference planes move properly. Let's try another value. Now, let's change the table length, and again click the Apply button to verify that the reference planes move as expected. We can repeat these steps to systematically test that each of our parameters is having the desired effect on the reference planes. Now let's switch to the elevation view and check out the table height parameter. This parameter is also working properly. Back in the Family Types dialog, we can define a few types with different dimensions that we can use for testing our new table component. Click the New button in the Family Types section of the dialog and enter a descriptive name for this new type. The current dimensions are copied into this type. We can change these values or define another new type and change them there. When we're done, we'll have several different types to choose from. You can see them here in the Name dropdown. These will be the names that appear in the Type selector. We're now ready to add forms to our component. We can add solid forms or void forms, and use any of the form generation methods, extrusion, blend, revolve, sweep, or swept blend, to define these forms. To make these forms dynamic and resizable, we will use our reference planes to define key aspects of their geometry. That way, when a reference plane is moved, the forms will be resized too. Let's see how that works. Switch to the reference level plan view and we'll create an extrusion to model the tabletop. Sketch the boundary for this extrusion in the center of the drawing area. Then use the Align tool to move the edges of the boundary and lock them to the reference planes. Do this for all 4 sides of the extrusion. Click the check mark to finish editing the extrusion. Then, let's switch to the elevation view to set the top and bottom of the extrusion. You see the extrusion we just placed at the reference level. By default, its start is at 0 feet and its end is at 1 foot. Let's use the Align tool again, this time to lock the top of the extrusion to our reference plane for the top of the table. The table shouldn't extend all the way down to the reference level. So let's add another reference plane to control the bottom of the tabletop. Then, use the Align tool to lock the bottom of the extrusion to it. Next, we'll add a dimension to set the thickness of the tabletop. This dimension will extend from the reference plane at the top to the reference plane at the bottom. Always be careful to dimension to the reference planes, not the surfaces of the form. You may have to use the Tab key to select the reference plane when adding the dimensions. Let's set this dimension to 4 inches. We'll leave this set as a fixed value for now, so the tabletop will always be 4 inches thick, regardless of the table height. Now, let's switch to a 3D view and confirm that the form resizes properly as the parameters are changed. Open the family types and choose different types or change the parameters and click Apply. As we make changes, our new tabletop form changes its size based on those dimensions. We can repeat these steps, adding reference planes and creating a new form whose shape is defined by these planes to model another piece of the model. We'll add a pedestal base beneath the tabletop. Switching back to the plan view, you can see that we've added reference planes and parameters to define the pedestal length and pedestal width. Then in elevation view, you'll see that we've added another extrusion that stretches from the reference level to reference plane at the bottom of the tabletop. Open the family types again. Now we'll confirm that the two forms are responding properly to changes in the parameters. Each instance placed in the project.